When you step on a sharp object, we do withdraw our leg immediately, but one of the leg remains on the ground firmly to make sure that we stabilize such that we don't fall down. Have you ever asked yourself why this happens? It means even the leg which is remaining on the ground has to get a message so that it becomes even more firm to make sure that we don't fall down. This is an example of what we call crossed extensor reflex. Good evening to you all. TUMNAD in front of you. Today we are going to be looking at what we call reflex arc. And during this study, we are going to be looking at the different types of the reflexes, classification of different types of reflexes, and all that. So before that, if it is your very first time to watch me, please make sure you subscribe, you turn on the notification bell so that whenever I load a video, you become the very first person to watch. So let's go ahead and get started and look at what we call the reflex arc. We need to first know what a reflex is, and simply a reflex is going to be a rapid, and this rapid is going to be rapid predictable, and involuntary response to a stimulus. Okay, to a stimulus. So now the rapid involuntary predictable response to the stimulus is what we call a reflex. Okay, and these reflexes are very important. They are going to be protecting us in some of the dangerous situations, and also they also help us to know the health, how healthy the nervous system is. Okay, we use these kind of reflexes. Okay, so now let's talk about what a reflex arc is. Now, when we talk of a reflex arc, when you hear of the word arc, let me first draw something like this. If this is my circle, and if I do something like this, so now this becomes an arc. So now if I rub off this one, okay, if I rub off this one becomes now our arc. What does this one mean? It means that our reflex arc is going to be having this kind of movement, okay? The information has to come, like for example on this diagram, the information has to come, okay, via the sensory neuron, and then it has to undergo the integration center, and then it has to exit. You can all see this is going to be like more of an arc, okay? It's going to be more of an arc, which is going to be equivalent to this structure which is remaining there. So it is more of an arc, okay? That's why it is called a reflex arc, okay? So now, in that way, this kind of neural pathway which is in this arc is what we call a reflex arc. In other words, a reflex arc is a neural, okay? Is a neural pathway, that controls the reflex action. Okay, that is just a simplified definition of a reflex arc. It is a neural pathway that's going to be taken by an electrical impulse. In other words, from the site of origin of an electrical impulse to the central nervous system and then back to the effectors. That is what we call a reflex arc. Okay, now having looked at that, let us look at what we call the types of the reflexes, or you may say we're going to be classifying these reflexes. So let's go ahead and see the classification of different types of what we call the reflexes. Okay, so we are looking at what we call classification. Okay, we are looking at what we call classification of reflexes. So now, looking at classification of reflexes, we have a couple of the classifications. Okay, and it is within these classifications that we shall be generating the different types of reflexes. Okay, so let's go ahead and get started and see the different classification of reflexes. We are going to start classifying these reflexes. The first one is going to be we are classifying them by development. Okay, by development. Okay, and when we are studying it by underdevelopment, we are going to be seeing we have such kind of reflexes that are inborn, and we even have those ones that we acquire. Okay, So in other words, we have under this one, we have what we call inborn, and then we have what we call acquired. Okay, and of course, under inborn, we are going to be having a lot of reflexes that are inborn. For example, we have what we call the circling. We have what we call the circling. We have what we call the rooting. We have what we call the rooting. Also have what we call palmar grasp. We have what we call the palmar grasp. And there are very many reflexes under inborn. We are born with them, okay? And then when we talk about the acquired, we have a typical example is going to be driving. It's going to be driving and also salivation. Okay, and also salivation. You know, when you smell food, we do salivate. So such kind of the reflex is going to be acquired. Okay, and this was explained well by one of the scientists called the Ivan Pavlov when he used the different dogs. And when we talk about the driving reflex, this one is like when you're driving a vehicle and you suddenly meet people in the corner, you automatically you apply brakes. Okay, so now that kind of automated response, this is going to be under what we call the acquired classification of the reflexes. So now that is number one. Number two, we are going to classify them by response. Okay, by response. Okay, by response. And during the study of classification by response, we are going to be having number one, somatic. We are going to be having somatic reflexes, and we can also have what we call autonomic. Okay, we can even have what we call autonomic reflexes. Okay, autonomic reflexes. And now when we talk about somatic reflexes, and here we are going to be having the effectors. Okay, the control structures are going to be the skeletal muscles. Okay, our effectors are going to be the skeletal muscles. Okay. And of course, when we are talking about the autonomic reflexes, this is going to be more of the control of the visceral organs or visceral structures. Okay, it's going to be more of what we call the visceral structures. Okay, and when we talk of the visceral structures, here we may mean the heart, we may mean the glands, and even we mean also even the blood vessels. Okay, even the blood vessels. So now, generally in classifying based on the response, you have what you call somatic reflexes and then autonomic reflexes. The somatic reflexes is going to be dealing with what we call the control of the skeletal muscles, and then autonomic reflexes is going to be dealing with the visceral structures, like control of the heart and then glands and then different blood vessels. Okay, that's our second classification. So now let's look at what we call the third classification of reflexes. Okay, you can also classify them. By sight. Okay, this is going to be now our third. Okay, it's going to be now our third classification. We can classify them by sight. Site of integration. Now, by the case of by classifying by the site of integration, we are going to be having the brain and then also the spinal cord. So now those reflexes that their integration center is the brain. They are what we call cranial. Reflexes. Okay, they are what we call cranial reflexes. And those reflexes that are their integration center is the spinal cord. We just call them spinal reflexes. Okay, spinal reflexes. And these kind of the withdrawal reflexes are going to be part of the spinal reflexes. And then of course the cranial reflexes, they are very, 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 very many. Like the cough reflex, the sneezing reflex, like the gag reflexes. All these are going to be more of what we call the vomiting reflexes. They are going to be part of what we call the cranial reflexes. But these kind of the stretch reflexes, withdrawal reflexes, crossed extensor reflexes are going to be part of the spinal reflexes. Then what else? Number 4. We can classify them by the number of synapses. And here, when we are talking about the number of synapses, we want to know how many synapses are going to be involved in a particular type of a reflex. Okay, and during that, we are going to be having what we call monosynaptic, and then we have what we call polysynaptic. Okay, and with this, a classic example of monosynaptic is what we call stretch reflex. Okay, stretch reflex. And again, it means that here we are going to be having one synapse. It means you're going to be having a sensory neuron and a motor neuron involved, making one synapse. Okay, but when we come to what we call the polysynaptic, it means we are going to be having more than two, or even two or more synapses. That means we may have the sensory neuron, there is an interneuron, and even also the motor neuron. A classic example of polysynaptic neuron is going to be the withdrawal reflex, and even also crossed extensor reflex. Okay, so now typically these are the four classification of what we call reflexes. So now, having looked at this, let's go ahead and see what we call the reflex arc, which was our main reason of this study. Okay, so now having looked at the classification of reflexes, so now let's look at what we call a reflex arc. We have said that a reflex arc is going to be that neural pathway that's going to be mediating what we call a reflex action. Now, when you see this kind of the diagrammatic classification, it is going to giving us what we call a reflex arc. So now, what are the components of reflex arc? Okay, components of reflex arc. Okay, components of reflex arc. Now, in a component of reflex arc, we have what we call a stimulus. We need to have a stimulus that's going to be stimulating our sensory receptors, which are going to be located in the skin. Okay, for that reason, for anyone to say that you have a reflex, for example, you are touching on a hot object, it means we need to have a sensation. We need to have what we call the sensory receptors that are going to detect a stimulus. And in this way, we have brought our kernel, which is going to be serving as a stimulus. Okay, so now our first component of a reflex arc is going to be now the sensory receptors that are going to be detecting this kind of the stimulus. Okay, so our first component is going to be our sensory receptors. Okay, sensory receptors. And what are the sensory receptors going to do? They are going to detect the stimulus and then convert into an electrical impulse. Okay, and that process of converting the stimulus into an electrical impulse is what we call transduction. For that reason, our sensory receptors, they are going to do what we call detecting. They are going to detect the stimulus, and then after detecting the stimulus, they will transmit it, or they will convert it into electrical impulse, which is what we call transduction. Okay, So now the sensory receptors are going to be detecting the stimulus and then convert into an electrical impulse. So now our starting point, or our first component, is going to be here. This is going to be our sensory receptors. Now, once electrical impulse has been generated, it has to be transmitted through this kind of fiber and then enters into the spinal cord. How do we call this fiber? This is going to be a sensory neuron. So now this becomes now our second component. So now our second component of the reflex arc, our second component of the simple reflex arc is going to be what we call the sensory neuron. Okay, the sensory neuron. And now the sensory neuron, its primary role is going to be picking and carry these signals and take it to the central nervous system. Okay, so now the primary role of these sensory neurons in this reflex arc, they are going to carry signals. They are going to carry the signals to to the central nervous system, and in this case it's going to be now our spinal cord. That is it. And because they are carrying the signals towards the central nervous system, we say now they are more of afferent. Okay, they are more of afferent. Okay, they are more of afferent. Okay, afferent pathway. Okay. Now, what's going to be now our third area? Our third component of the simple reflex arc is going to be, you see this area, when this kind of the signal reaches the spinal cord, we have this kind of the neuron. You see this neuron? This neuron is going to be now our third component. Okay, it's going to be our third component. It is an integration center having this kind of neuron, which we call the interneuron. Okay, so now our third component is going to be now the integration center. Okay, it's what we call integration center, and in this case it's going to be now what we call the interneuron. Okay, what we call the interneuron. So now once the interneuron receives the signals from the sensory neuron, it will now command and stimulate these kind of the neurons which are going to be located on the ventral horn. Okay, you see these kind of the neurons which are located on the ventral horn, they are going to be now receiving the information from the interneuron, and then they bring out the motor response. Okay, so now this kind of the integration center is going to be more of a control center. Okay, it's going to be more of a control center. Now, it is the one which is going to be stimulating, or is going to be the one going to be activating the cell bodies of the motor neurons to come out from the ventral horn through what we call the ventral root. So now our fourth component of the reflex arc is going to be what we call the motor neuron. Okay, the motor neuron. And because the motor neuron is carrying the information away from the central nervous system, we say this kind is going to be efferent. Okay, it's going to be efferent pathway. And generally, these motor neurons, they're going to be carrying the signals away from the central nervous system. That is their role. Okay, they are going to carry signals. They are going to carry signals away from central nervous system. Okay, they are carrying a motor command from the central nervous system to the far effector. So now this is going to be our number 4. Okay, the motor neuron. Now, when they carry these kind of the signals, these signals are more of a command, and they are going to the effectors. And in this case, our effectors can be glands, can be skeletal muscles, which are going to be receiving that kind of command. Okay, so now this is going to be now our number 5. Our number five component of the reflex arc is going to be now our effectors. Okay, it's going to be now our effectors, and our effectors can be glands, or even skeletal muscles. Okay, even skeletal muscles. Now, depending on our example or illustration of this example, you realize that here we are going to be having now our skeletal muscles that has to contract such that you pull away the hand from this kind of dangerous situation. For that reason, you're going to be having contraction of the skeletal muscles. We're going to be having what we call contraction of the skeletal muscles. Okay, so now our reflex arc will say it will have been completed, because when you touch a hot object, the sensory receptors are going to pick the information. It will pass through what we call the sensory neuron, through what we call the dorsal root. Okay, and then pass through the dorsal root ganglia and enters into the dorsal horn, whereby it's going to be synapsing with the interneuron, which will command the motor neurons, which comes out from the dorsal horn through what we call from the ventral horn, through what we call the ventral root, and then becomes part of the spinal cord, and then comes out. It goes to the effector, and it causes a response. Okay, it is such a beautiful thing, and these kind of reflexes are going to be protecting us from dangerous situations. You know, sometimes when you touch something very hot, we do withdraw immediately, even without involvement of the brain. These kind of the reflexes, in most cases, we don't involve the brain. You can imagine by the time the brain is informed, the stimulus will have injured you extensively. For example, if you wait for this message to move up to the brain, these fingers or any kind of the stimulus would have damaged you extensively severely. That's why these kind of reflexes, like the withdrawal reflexes, does not involve the brain. It is an automated response. Okay. We said that a reflex is that automated, predictable, involuntary response. When we say it is predictable, it means that even when you bring the same stimulus, it will be the same kind of the response, meaning that it is a predictable response. Okay, that's why we call it predictable. It means that even following repeated kind of the stimulus, if they bring the same stimulus again, the same neural pathway will be involved. That's why it's going to be a rapid, predictable, involuntary response, okay, to the stimulus. It's such a beautiful thing, and these kind of reflexes are going to be helping us in protecting us from dangerous stimulus, and even also we can use them in medical diagnosis of the health, okay, of the health of the nervous system. Okay, some kind of the reflexes are going to be used in what we call determining the health of the nervous system. Okay. So now this covers a simple reflex arc, having the sensory receptor as the first component, having the sensory neuron which carries the sensory signals to the central nervous system, having an integration center which is going to be the interneuron, and then the motor neuron which is going to carry out the signals away from the central nervous system, and then finally to the effectors, which can be the skeletal muscles. It can also be the glands, and then it will respond accordingly. Okay, so now that covers reflex arc in simple. And if you think whatever I've talked is making sense, is adding to you, you're really benefiting, please make sure you like the video, comment in the comment section, share the video to people whom you think is very helpful, and don't forget at the end of it all, subscribe. Thank you very much for listening. It has been TUMNAD from the beginning of this tutorial up to the end, and TUMNAD as always until we meet next time.